Good morning, good afternoon, or good evening, depends on where you are. My name is Bing Yu. I'm the Chief Data Scientist and Analytics Architect at Infoblox, leading research and development of AI technology for malware detection, DNS security. So today I'm going to talk about the AI-powered DNS firewall, start from DNS security, and why we need AI technology, and briefly talk about the AI technology, including neural network, deep learning. And more importantly, I would share with you our 3 detection models, including fast flux detection, DNS exfiltration, and infiltration detection. And the last one is the inland DGA or domain generation algorithm detection. Finally, I will share with you our DNS service. Okay, as we know, all the network is vulnerable. So here is just some big instance that happened years earlier. In 2013, as we all know, Yahoo has about like 1 billion email accounts got affected. So that cost Yahoo about like $350 million in the transaction with Verizon. In 2016, 2 years ago, there's a big DDoS attack from 400,000 botnets across more than 160 countries. At the peak time, the volume is about like 1 terabit per second. As you know, not any single device can deal with such big volume. Last year, 2017, at Equifax, everybody knows more than 145 million accounts got affected. The estimate cost is about like 4 billion. Last year again, more than 200,000 machines across more than 150 countries got affected by WannaCry. That's the biggest attack by ransomware. The estimate cost is about 4 billion again. So how those kind of attacks happen? So typically, DNS is the starting point for any network transaction. So network, you have firewall for the security, but DNS typically not watch or firewall in a typical environment. According to Cisco publication in 2016, more than 91% of the malware are using DNS for attack. So they use DNS to gain command and control, data exfiltration or infiltration, to update the malware, and to redirect the traffic without your knowledge. Let's take a look at this picture, how DNS plays a role in those kind of attacks. In the very first stage, those bad guys will send you malicious emails with phishing links. So when you click those links, you actually get the DNS resolution. And then you actually move to the second stage to download the binary and install those malicious malware on your system. That also goes through DNS for the resolution. So at the time of attack, they will actually use DNS to resolve the domain name, to get the content control, to send you WannaCry instruction, to do data exfiltration, or to update malware. So if we can secure DNS, it's clear the network can be secured in the first place. So why we need artificial intelligence to help us for network security? Let's take a look at the old school time. Typically, when you get the attack report, you collect the binary samples. You do the reverse engineering to identify the signature. Then you create the rule-based detection, or you put those kind of signature into blacklist, or you can do the DPI. But the problem here is those kind of approach is labor intensive, definitely not scalable. And most likely the signature you identify can be week or months old. Over the time, we are generating more and more signatures. The blacklist is getting bigger and bigger, but on the other side, the hit rate is going down. That means it's getting less cost effective. The reason is because typically the human being can see 1 dimension, 2 dimension, up to 3 dimensions. But right now, the advanced persistent threat APT is getting higher dimension. It's changing much faster than before, and the attack scale is getting much larger than before. So it's way out of our human reach. So that's why we need an AI technique to help us in this task. So let's take a look at this example. If you get a single attack, you can hire security engineer to do analysis to identify if this is malicious and get the signature. If you get this many, you do the process again, then again. But you know, too many attacks will overwhelm your approach, so it's not scalable. What AI can do is to, based on those instances, to draw a region for you automatically. So it can identify this region is malicious. So next time there's a new attack coming, if it's inside this region, it can automatically identify this as a malicious attack and that has the same behavior as the others. If it comes outside of the region, it can tell you this is not malicious. AI has many different approaches. Currently, the most popular and successful approach including deep neural network. This is a typical example about deep neural network. You have multiple layers. The left side layer is the input layer, and the right side layer is the output layer. In the middle, you have multiple hidden layers. Once you have a network, the key to get this job success is the data. So at Infoblox, we have data coming from our large number of customers and also from the third party. In total, we have about like 12 billion DNS queries every day. We have collected data over 2.5 years. So in total, we have about like 1 petabyte data. So once we have the data, we have a team of data scientists to build AI models. In addition, we also have 3 top universities at the United States to help us to build a model. When the model is get created, we put the model into our product. So we have an ATC product that's on the cloud, and also we have on-prem solution that's a NIOS. Once you get the model into the product, how you do the scoring, how you do the online detection. So that's the architecture. On the left side, we get a DNS query into a queue. Then we put the data into a streaming engine. Streaming engine actually gets data into observation cache because our technique is behavior analysis based. So you need to observe a threat for a certain amount of time to decide if it's malicious or legitimate. So that's why we need a cache for observation. So once we have enough observation, then we have an AI engine to do detection. This AI engine supports a number of models. I'm going to actually give you details in the following slides. So then once the detection finished, you get output for mitigation or for reporting. So the very first model we developed is called fast flux detection, or you can call it IP fluxing. Fast flux is something you have a domain name sent to the DNS, you get the answer back. But over the time, this answer can change. The IP can change. The reason they change the IP is to bypass blacklist firewall. Fast flux is a technique that can be used by malicious for CNC control. or for WannaCry ransomware instruction. And it also can be used for legitimate purpose, like CDN, load balance, NTP, or peer-to-peer communication. This is the example of the fastflux IP address for a domain listed on the top. So this domain actually generates a large number of IP addresses over the time, but each doesn't have a high frequency. You can see the first column is the IP address, second column is the frequency, and so on. We did a study over 6 months worth of data, and we identified this fastflux attacks is across the whole country in the United States. So this table shows you the frequency and the number of flux domain in the first column, and the ASN and ASN name. So you can see it happens everywhere. The second model I would like to share with you is the data exfiltration, infiltration detection. Let's take a look at this example. If you have a compromised system behind a firewall, you try to send DNS queries over the firewall will not block it, right? So this query will get up to the recursive DNS servers, then all the way down to authoritative DNS server that happen to be owned by a hack. So that actually creates a tunnel between the compromised host and the hack-owned DNS server, right? Using this tunnel, they can send a query looks like that. So this is a malicious DNS query that contains a password. So this password gets sent out through the firewall. DNS tunnel can be used for malicious, such as data exfiltration, malware update, and also can be used for legitimate use, like AV vendors. They use tunnel to do communication. Also, a lot of IoT devices are using DNS tunnel. So what we want to do is to detect DNS tunnel and also identify which one is malicious, which one is legitimate. So here are some examples of DNS tunnel payloads. You can see those DNS queries contains encoded string. Those are the DNS tunneling payload. The third model I want to share with you is called domain generation algorithm, or DGA, or you can call it domain fluxing. Here are some examples of DGA domain. So DGA is an algorithm. It will generate large amount of domains from an algorithm. They look like randomized. So most of the DGA generated domains will not get resolved. So that's why you see an X domain. But one or few of them do get resolved. That actually creates a communication between compromised system and the CNC server. From very earliest time, the bad guy just used a static IP address for CNC communication. But that technique is no longer working, so that's why they moved to fastflux. They use a static domain and the flux IP address. But that technique also is no longer working because we have fastflux detection. So they moved to this last result. They use flux domain name to contact CNC. So according to some study, 93% of the system in the world had DGA infected. So at Infoblox, we developed a technique called inline DGA detection. Let's take a look at the DNS server from this picture. So in the real traffic, a DNS server gets a request from the left side. It will do the resolution on the right side. For those DGA generated domain, as I just mentioned, majority will get NX domain. That's on the bottom right side. So basically the output can be resolved on NX domain. From this picture, we can actually abstract the problem of the DGA detection to this sentence. Given a domain name, tell me the probability of it being an NX domain. So if we can detect a domain name it has high probability to be an NX domain. Most likely this is a DGA generated domain. DGA has a large number of families. Each family has different patterns, different behaviors. We just use this example to show you how complex it is. So let's say we have so many DGA domains, put them together in one picture. We want to build a model. So this model will be complex model. So that requires us to use deep neural network to deal with complex model. So this is the picture of the neural network architecture. It has 33 layers, more than 10 million parameters. Together, we are using 11 lexical features. We have 3 parallel CNN layers. CNN stands for convolutional neural network. We have more than 150 million samples to train this network. The top part is the CNN network architecture, and the bottom part is the deep neural network architecture for lexical features. We have 11 lexical features in high level that cover entropy, n-gram, alphabetic character ratio, Wolf character ratio, and domain name length, and top level domain name. Okay, once we have this inline DGA detection classified, we put this into our product. So the product will look like this picture. So you get query from left side, you send a query to classify, same time you send a query to the DNS resolver. So you get output from each of them. When you combine these two outputs together, we can do online learning, because if the classifier tells you something different from the resolver tells you, so you can actually retrain the classifier online. That's called online learning. Here I want to share with you our product. The typical DNS server looks like this one. You get a request to the DNS server, then the server will send a request to the recursion if it's not cached. With the inline detection, we can add this component into existing DNS server. So when it detects this domain name is malicious, it can catch CNC IP address in real time. The benefit actually is to classify DNS requests on the fly in real time, and it can do zero-day detection. We target malicious communication. So once we identify this as malicious, we can just block this communication without affecting the compromised system. As I mentioned, this inline detection can capture CNC IP address, right? So that gives us flexible mitigation strategy. You can block IP address, you can block the domain name, you can block the host, right? And also you can do it in continuous online learning. So last one is the product architecture. It looks like this one. So left side is a traditional DNS server. We added RPZ firewall many years ago. That's the threat intelligence. With this AI technique, we can put this AI model into DNS server. So it can do inline detection in real time. So the technique we call the threat insight. To summarize, we are getting more and more advanced. DNS is the first place to block malicious attacks to secure network. Firewall no longer stop malicious DNS, such as data exfiltration, infiltration, DGA, or fast flux. So AI is a must to detect APT. AI-powered DNS service will be the future. With that, I'm open to the questions.
Awesome, Ben. This is very informative. I have received a couple of questions offline. So let me go through them first. And again, all of you, thanks for joining. And it would be great if you can add your questions in the Q&A. If you don't know where it is, just add them in the chat window as well. So let's take a few questions that we got already. So when, as you rightly said, it is very complex and it's inefficient to do this on a manual basis, right? Like adding the domains which are not malicious domains to the exclusion list and managing all these exclusion list problem. So, but the thing is, humans are a lot more, I mean, we have confidence on the humans. How do we trust that AI would do a, you know, if not better, at least equally good job?
Right, actually, that's a good question. Actually, that's the question not just for our technique, that's the question for all the applications using AI techniques such as self-driving, right? So people, have a concern if we let automobile, drive themselves, will it be secure or will it be safe, we had very similar question. But based on the statistics, based on the research over the long period of time, machine will be more reliable than the human beings because it's not affected by emotion, by other factors. Once you train a model, the model will repeat the performance over the time. The performance will not change. As long as you have enough samples to train an AI model, you can get a decent performance, say 99% of accuracy. So this 99% accuracy will be consistent. Of course, those malicious attacks or samples can change over the time. So that means the model needs to catch up the new evolution. So that's why we at Infoblox retrain the model over the time. So first thing, the model itself can do online learning. When it sees a sample, it doesn't meet the classification requirement or metrics, it will retrain itself. On the other side, every month, we will retrain the model offline. So every month, we will update the model into our cloud service. So that's the way we have the model up to date in terms of the new samples or new threat. So that's why we can do zero-day detection, right?
Right, yep. So I have a question here from the audience. Amazon Video, Google User Content, and many others are using legitimate exfiltration. So how do we make sure that we don't block these legitimate web services that would use the exfiltration technique?
Yeah, that's a very good question. As I mentioned to you, like fast flux or data exfiltration, those are just the technique anybody can use for good reason or for bad reason, right? So as this question pointed out, Amazon Video, Google, and many other AV companies, they're using DNS tunneling technique for communication. As you know, DNS actually has a number of query types, from A to quarter A to NS, MX, and TXT, and so on. A large number of DNS query types. TXT is typically designed for user to get a larger payload from the resource record or from authoritative DNS server. According to our study over 6 months worth of data, we find legitimate DNS tunnel tend to use TXT because TXT is the type designed for transferring large payload. Malicious tunneling tend to use query type A or quarter A. The reason is that because they think the security community will look at TXT type query closely because it can transfer large payload. So that's why this bad guy, they're smart, right? So they don't want to be monitored. They try to use query type other than TXT. So this is a good indicator, but that's not the only feature we are using to differentiate between malicious and legitimate DNS tunneling. I just gave you an example. So we have many other features to distinguish between malicious and legitimate DNS tunneling. That's a very good question. Thank you.
Thank you for answering. So one next question is, what attacks can be detected by on-premise threat insight in comparison to detection by threat insight in the cloud? So this is probably our existing product, right? Not related to the AI, but yeah, go ahead.
Right, so that's a good question. So we have two different types of provisioning based on AI technologies. One is on-prem, another one is in cloud. The difference between them is in cloud, we have almost unlimited resource to do AI detection, but on-prem, the resource is limited, right? So that's why today, on-prem, we provide the AI model to do data exfiltration or infiltration detection. That's the model we deploy on-prem. In addition, we also have another model to do DNS messenger detection. So DNS messenger is the attack I didn't actually mention in my presentation today. So it's a type of a new binary into a compromised system. So that's the DNS messaging. The on-prem can do that. The in-cloud deployment can do data exfiltration, infiltration, fast flux detection, DGA detection, DNS messenger, and many other things. One thing I want to emphasize here is that even we do the data exfiltration in cloud and also on-prem, but because of the resource limitation on-prem, the performance, the accuracy is a little bit different. So in cloud detection has better accuracy, better performance than on-prem solution. Yeah, that's a good question. Thank you.
Awesome. So there is one question, couple of questions. I think they are kind of interrelated, but the first is, are we getting any patterns using machine learning to detect DDoS, malware, and ransomware? Is there any common pattern that is emerging?
The answer is yes. The DDoS attack is actually included in the data exfiltration model because there's a very typical DDoS attack pattern that fall into data exfiltration or tunneling behavior. So that same model can catch DDoS attack when it's in large volume, high frequency. So we have a flag to tell customer, okay, this is the DDoS query. It's up to customer to decide if they want to block or they don't want to block. Because DDoS attack typically is to send a DNS query to a legitimate domain, such as google.com. So they put some random string before google.com, blah, 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 .google.com. Send this query to the Google authoritative DNS server, right? So it's up to customer to decide if they want to block or they don't want to block. Just put it into the monitoring, right? Yeah, I think that's a good question. As I just mentioned, 2 years ago, there's a big DDoS instance that happened at a peak time. The volume is more than 1 terabit per second, right? So with our AI-powered DNS server, we can block DDoS attack for you. Thank you.
Awesome. So one another question is, how much can we rely on AI to detect the DGA attacks? Is it, can we rely completely, or is there a hybrid approach we have to take?
That's a good question. We have performance metrics about our AI-based DGA detection model. So the accuracy, so first of all, when you talk about the performance of a machine learning model, you have two metrics, right? False positive and true positive. for the product, we try to get the false positive rate as low as possible. So our false positive rate is measured at 1 out of 10,000. So at this false positive rate, we measure the true positive rate is about 40%. But don't think about this 40% is not high enough. Let me explain it to you. A CNC IP address typically will be resolved by a large number of DGA domains. From our study, a CNC IP address can have more than 100 or more than 1,000 DGA domains associated to this one, right? So think about this large number of DGA domains. If you can detect 40%, that's good enough, right? If a CNC IP address has 100, for example, 100 DGA domains, you can detect 40 out of these 100 domains. That means you can catch this IP address sooner or later, right? So that's why it's guaranteed this model can catch CNC IP address for sure. So that's why in terms of CNC IP address capture ratio, it's 100%. In terms of the DGA domain classification, true positive rate is 40%. So that's the separate metrics. Thanks. That's a very good question.
Got it. Got it. So since we are on the subject of DGA, of course, we can have a way to, will DGA generation algorithm, will it change on the fly, like to confuse our AI solution?
That's possible, but we haven't actually see such a behavior. So when you say the pattern change, I mean, I understand, you know, if the pattern is significantly different, we haven't seen such a behavior. So a DGA algorithm is a piece of algorithm. So once the algorithm doesn't change, it will always generate the same, we generate the DGA domains in the same pattern. But the domain name itself can be different in terms of characters, number of characters, that's the size, or some ratio like alphabetical ratio or verb ratio. So anyway, change in a range, right? But if this DGA still using same algorithm, but it just changed the seeds, the DGA seeds, the pattern will not change significantly. So that's why we have the online learning to deal with those minor change. Inevitably, the DGA family can change over the time. So they can send different binary to the compromiser system. That's the malware update. So that can change DGA domain name pattern. That's why we have a monthly retraining offline. Every month, we will have a new model. During this month, we collect new samples from the real traffic. So that new sample actually can update the model with the new information. So that's the deployment schedule.
Right, right. So what percent of false positives are you seeing when you do the, you know, this kind of DGA detection?
Yeah, so as I just mentioned, so in any machine learning model, you have two metrics, right? False positive rate and the true positive rate. We actually set false positive rate at 1 out of 10,000. So that's the false positive rate, 1 out of 10,000. So at this false positive rate, we measure true positive rate. So the true positive rate, as I just mentioned, is around 40%. Right, so that's the, hope that answers the question.
Yeah, very good. So I have a couple of questions related to the product. So when do you see these features coming into these capabilities coming into the product, and are they going to be like a separate purchase item, or will they be part of the you know, product itself? Yeah,
that's a really good question about the product. may not be the right person to answer this question, but ideally I can tell you, we have a product package for user to choose you want to, purchase which model, you want to actually, purchase which package, right? So I would encourage you to contact our product management team for those information about, how to package the product, right? So we have much more accurate information for you.
That's fair. So let's talk a little bit about the team you have at Infoblox, and what is your charter and what kind of future research we can anticipate to get briefed down.
Yeah, so we have a team of data scientists in Infoblox. In addition, we also work with top 3 universities in United States. They have faculty, graduate students working with us, building machine learning models, doing experiments, testing, publication. We have a long list of initiatives to apply AI technique. We have built over more than 5 years, apply this technique to many different problems. So let me just give you a high-level picture about what we are going to do. So besides these machine learning models, including fast flux, DGA, data exfiltration, and also DDoS, first thing, we want to enhance those models to continuously improve those models for the performance, accuracy, right? We also want to add new models to detect IoT device and anomaly of the IoT device. And we also want to detect new malware or new threats associated to those big instances, as I just mentioned to you, ransomware, WannaCry, those kind of larger instances. So that's because working in network security, your job will never be ended. You always have a new challenge coming from the industry, right? But we have this AI technique as a foundation. We created this foundation over more than 5 years. So we can apply this technique to many different problems, to solve many different problems, right? Thanks.
Right. So one last thing, I know as Infoblox, we are committed to cloud and SaaS. How is this transformation in the industry going to help AI and specifically Infoblox research on AI?
Yeah, that's a good question. The whole industry is moving in this direction, so that can get rid of the burden from customer. You move all the infrastructure to cloud. Let cloud to take care of your business, right? Typically for the network. So this trend actually help us to collect large amount of data to train AI model. The key factor in AI business is the data. Once you have large amount of data, the accuracy of the model can be much better, and also the improvement can be much faster. So we are actually taking the wave of this trend at Infoblox. We have more and more customers moving from on-prem to cloud. So that's an advantage. And that will be the continuous trend. So that's why I certainly encourage our customer or potential customer to try our cloud provision. Yeah.
Yep. Well, Ben, it has been a pleasure to listen to you on some of these very exciting and most important topics as we continue to find the right tools and platforms to prevent these cyber attacks. So thank you very much. And all of us, we really appreciate your time joining us, and you will get a link to the webinar archive subsequently. Thank you very much for joining.
Yeah, thank you everyone for attending this talk. Bye.